Okay, welcome back. This time we want to continue kind of our exploration of fractions, but now with variables. And we're going to look at multiplication and division with rational expressions. Okay, and basically all we're doing is retracing your education of fractions, but now with variables. Okay, so it's not really all that new. So we begin with multiplying and have you recall sort of what you did in arithmetic. So recall 5/2 times 3/7. So how do we do that? We just multiplied straight across. 5 times 3 is 15. 2 times 2 times 7 here is 14. Here's a more complicated one, 10/3 times 21/5. So if you try it this way, it's 210 all over 15, which is kind of a bummer because now I got to figure out, what do I divide top and bottom by to simplify? And what I claim is there's an easier way. You can kind of get around having this difficulty of, okay, I got to divide 210 by 5, 4, 2, and then 15 divided by 5 is 3. And then I think 42 is divisible by 3. So 1, 3, 1, 2. And then I got 14. So this is equal to 14. Right? So, I mean, that works in arithmetic. It gets the job done. But what I'm saying now is it's really not the best way to do things. Okay? So the way we want to get you, or way we want you to do this is to kind of don't multiply it out. These things are already kind of factored, and it's easier to just, well, let me show you. Okay, so 10 is 5 times 2, 21 is 7 times 3, all over 3 times 5. I can remove the 3's, remove the 5's, and what are you left with? Well, 2 times 7 is 14. So hopefully you can appreciate, here's the work that I'm avoiding. And on top of that, it's going to be a lot worse here in variable land. If you insist on doing this, it's kind of like a back and forth. You go and you multiply it out, and then you're going to have to factor it again. Whereas this thing is kind of already factored. And if you just take one step lower and factor it even more, it's quicker to go ahead and remove common factors and then multiply out. Okay. So we want this method for dealing with our variables. This turns out to be the go-to method. Okay. So hopefully you've seen that before, and let's take a look at it now in this new context. So 8 all over x minus 2 times x plus 5 all over 3. These things are pretty much already factored. I mean, if you wanted to, you could factor 8 into 2 times 2 times 2. It wouldn't make very much sense, but you could do that. And then times the x plus 5 all over the x minus 2 times 3. And then you see there's no common elements. There's no 3 up here. There's no x minus 2 up here. And likewise, there's no 2 down here and no x plus 5 down here. So there's nothing you can do about it. And in those cases, you just multiply out. Okay, so this would be, this is 8. So I want to distribute that to those two terms. And I get 8x plus 40. Downstairs, I want to distribute the 3, and I'll have 3x minus 6. Okay. Let's look at 8. So I have x minus 2 all over x plus 9 times 5x plus 45 all over 2x minus 4. So again, I don't want this method where I just multiply the heck out of it and then try to simplify. Okay? Again, that sort of approach will work in arithmetic classes, but not here. Okay? You want to factor as you go across. So x minus 2 is already factored, x minus 2. And then I can factor this guy. There's a GCF of 5. So I could pull out a 5, and I'm left with x plus 9. Downstairs, I have the x plus 9. And then I have, I'm going to pull out a 2 from this guy. So 2 times x minus 2. So after you factored, you can clearly see the parts that need to be removed. The x plus 9 over x plus 9, same as 1 over 1. X minus 2 over x minus 2, same as 1 over 1. And we're left with 5 halves. So factor as you go across. Let's look at 14. What do we have here? So 9y plus 21 all over y squared minus 2y. So in the numerator, I want to factor, okay? Whoops, I forgot the thing I'm multiplying by. Y minus 2 all over 3y plus 7. Okay, so as I go across, I want to factor. So from this guy, I'm going to pull out the 3. So I have 3 times 3y plus 7. And then the y minus 2 is already factored, so just leave that alone. All over, I can factor out a y here, so I have y times y minus 2. And then times, this guy is factored already, so 3y plus 7. Right, so clearly, I have common factor here, common factor here, and you're left with just the 3 over the y. And that's it. Let's look at just 1, 2, 3, 3 more, and then we'll look at division. Okay, so number 10, I think it says 3y squared plus 17y plus 10 all over 3y squared minus 22y minus 16 times y squared minus 4y minus 32 all over y squared minus 8y minus 48. Okay, so factor, and there's a lot to factor here. So firstly, this polynomial, I believe it's quadratic, so we're going to go 3y and y, and then probably 5 and 2, or 2 and 5, right? So plus 2 plus 5. Then I'm going to factor this guy, hopefully, right? It may not be factorable. Y and y, it's got to be plus minus, and then we're thinking 4 and 8, right? Where 8 has to be the negative guy. So if you did all your homework, it's really going to pay off in this section. Factor this guy. So it's like 3y and y. And then, can we go with 16 and 1? No. 8? Yeah, 8 and then 2. So you want 8 to be negative, and then 2. And then finally this guy, so y and y has to be plus minus. And then I'm thinking like 8 and 6, no. 24 and 2, no. 12 and 4, okay, where the 12 is negative. Okay, and then for the fun part, you just start removing the common terms. Don't get too carried away. Okay, we're just left with y plus 5 all over y minus 12. Let's keep going. There's number 20. So x squared plus 5x plus 6 all over x squared plus x minus 6 times x squared minus 9 all over x squared minus x minus 6. Okay, so again, all you're doing is factoring the heck out of it. Factor that guy too. So this first one, x plus, looks like 6 and 1. Second guy, xx plus minus, 3 and 3. Downstairs, x plus minus, the big one's 3, the small one's 2. X plus minus, this time the big one is negative. Okay, start removing stuff. Well, that's about it. If you want to, you can go and, did I miss something? Ooh, I screwed up the factorization on this one. So yeah, I'm ripping through it. I just messed that up. Sorry. So x plus 2. That's what I get for not checking my work. Always check your work, right? All right, one more. 26, 8x plus 2, all over x squared minus 9 times 3 minus x, all over 4x squared plus x. Okay, so again, it's a matter of factoring. This guy looks like it has a GCF of 2. Downstairs, this is a difference of squares, so x minus 3x plus 3. And then this guy I can factor out an x. And I'm left with 4x plus 1. So usually you'll have cancellations. In the real world, it's not as nice, but at least here. Oh yeah, so there's one funny issue here. These guys are opposites. So you want to be a little bit careful there. You know, it's a negative will result when you when you simplify. So in the numerator, 2 times 1 times negative 1 is negative 2. Denominator, x times x plus 3. And you leave it in that form. Okay, so there's multiplication. Division is pretty much the same thing, except you just have that one additional step where you change the division symbol into the multiplication symbol and take the reciprocal, right? So let's take a look at that. So section 2. Division. And we want you to recall how this worked. So 3/5 divided by 21/10. Okay, so how did that work? You took 3/5 and then you multiplied instead of divide. You changed the division symbol into multiplication and then flip the second term, right? Let's take the reciprocal of the second term. So here we go. That's great. We can simplify a bit. 3 times 5 times 2, just factoring the 10 and the 5 times 2. Here I have 5 times 21 is 3 times 7. And then we could clearly see the things to remove, and we're left with 2 over 7. Okay, so it's the same deal, except you just have this one extra step, you know, bummer. Okay, so let's hit a bunch of these. Number 36, you have x over 5 divided by 20 over x. So it's very, very tempting to simplify this right off the bat, right? You think, oh, 5 goes into 24 times, and now be patient, okay? So they're trying to trick you. Take the reciprocal, multiply, so I got x over 20. And it turns out here, there's nothing you can remove. There's no common factor, right? There's no 5s up here. There's no x's down here. So it's just going to be x squared over 100. That's it. Let's keep going. 42, we have 4 all over x minus 6 divided by 40 all over 7 x minus 42. Okay. So first step, change it to multiply and take the reciprocal. Next step, I'm going to factor the heck out of this stuff. So I'm just going to leave the numerical parts alone and presume we know how to simplify that. For this part, the binomial, I can factor out a common GCF of 7. Okay, so I'm left with x minus 6. Downstairs, I have x minus 6 times 40. So I can remove the x minus 6's. 4 all over 40 is the same as 1 over 10. And then I'm just left with 7 over 10. Just 2 more. 46 y squared plus 4y minus 5 divided by, so this entire expression divided by y squared minus 25 all over y plus 7. Now, if you don't like this form, you can always write it over 1, make it look like everything's lined up. Okay. We'll change this to a multiply and then flip it. Okay, and then factor the heck out of everything. So I have y plus, y minus. Looks like it's going to be 5 and 1. And then I got y plus, and it's all over y minus 5, y plus 5. Okay, so it looks like just the y plus 5's will go goodbye, and we're left with the y minus 1, y plus 7, all over y minus 5. Okay, and I just leave it like that. One more. What do we got? 54. 3y squared minus 12 all over y squared plus 4y plus 4 divided by y cubed minus 2y squared all over y squared plus 2y. Okay, so flip it. I'm going to start already going at factoring just for the sake of sanity and time. Here we have GCF of 3. Downstairs, we'll have y plus plus, and I think 2 and 2. This will turn into multiply and then take the reciprocal. Okay. And now you want to factor. So 3 y squared minus 4 is the same as y minus 2y plus 2. It's a difference of squares. And then I could factor out a y from these two terms. Downstairs, I have the y plus 2, or y plus 2 squared if you want to get jazzy about it or whatever. GCF of y squared here, and then I'll be left with y minus 2. Alrighty then, let's start cracking at it. This is the fun part, in my opinion. So far we have 3y all over y squared. Y squared is the same as y times y. And then you can remove a factor of y. And 3 times 1 is 3, all over 1 times y. 3 over y. Okay. So I mean, once you get the hang of it, it's kind of fun, but you know, it takes practice. It takes doing your homework every day. And you just keep on trying and you'll get there. You'll get it done. Okay? You can do it. All right, see you next time.